Welcome back, students. It's Miss Murphy. We are continuing to learn about systems of linear equations. And this time we're going to look for a combination of numbers that has a difference of 6, but it has a sum of 6 also. So if you subtract them, you get 6, but if you add them, you get 6 too. So do you think it's possible? Last time we said no, and we were able to find a combination of numbers with um, those requirements. So I don't know. This time I'm just gonna kind of guess. I don't have the numbers in my head quite yet, but I'm just thinking ahead that possibly if I did some more thought or some in-depth work that I would be able to find two numbers. Okay, write equations to graph numbers that satisfy each constraint. So the first explanation, this sum is 6. Sum means add, so that means if we add two numbers, we're going to get 6. And the next constraint, if you subtract two numbers, you're going to get also 6. Now the graph is showing up over here, and just as we anticipated, there is a location where the red and green line are intersecting, so we know those are the numbers that are going to work. So right here, let's see, 2, 4, 6, 8, 10. It looks like they're counting by 2. So this would be the coordinate point 6, 0. And 6 plus 0 is 6. And 0 minus 6 is, well, no, it'd have to be 6 minus 0 to get a positive 6. Yeah, so 6 and 0. So it does exist. Um, so because the two lines are intersecting, that means there is going to be a solution to this problem. Okay, write equations. What about the sum is 12 and the difference is 5? So use that same equation. We're adding to get 12, and then we are subtracting to get 5. So because there is a location, and I can see here this is not an integer location, so this might be some fractions or decimals, but it is possible to find some values that will satisfy the constraints. So we say yes. There is one solution at the intersection point. Excuse my spelling. Still waking up this morning. Okay, we can try it again. This time they add to be 6. They also add to be 7. So these both say sum. So they add to be 6. There's that line. And they also add, oops, to be 7. Okay, unique situation here. There's no intersection point. These lines are parallel. So there's not going to be a solution for this constraint. There are no numbers that you can think of that would add to get 6 that also add to get 7. That's impossible. So for this one, we're going to say no. Um, Parallel lines have no solution to the system. Okay, so sometimes it's impossible and sometimes it's possible. How do you know? Well, we just did an example of not possible, and they were both adding. So it's kind of difficult when you're adding two of the same numbers to get different answers each time. So we could check these two. I mean, I hate just to have you try to do everything with mental math. So let's do a little bit of checking. How about check that bottom? The sum is 12 and the difference is 5. And as long as the lines intersect, then we know there's a solution. So that one works. That's possible. Um, Now the sum is 6 and the difference is also 6. We did that example, so we know that one's possible. Um, the difference is 3. The difference is also -3. Now you have two of the same thing, so you can't subtract and get one answer and then subtract and get a different answer. If you subtract, you're going to get the same answer every time. So whenever it has the sum, difference, you know, that's going to be impossible. How about this one down here? The sum is 7, so we're adding to get 7, and then it says product. Product is multiplying, and you can do multiply like that, and Desmos with the dot, multiply to get 12. So that might look a little interesting because it's not a linear relationship. And if we zoom in here, there's actually two different locations for solution. So 3 times 4 is 12. And 3 plus 4 is 7. 4 times, so it's just reversed. So, but this is possible because we're seeing some intersection points on the graph. That one's unique because the graph is not all linear. All right, let's try this last one to see if it's possible or impossible. So the sum is 2. One number is twice the other number. So if you double one of the numbers or multiply it by 2, then you're going to get the other number. That would be the equation to represent that. So yeah, there's a solution here. We have, you know, not whole numbers, but there is an answer that is possible. Okay, so we have all of our things matched up accordingly. Let's see what else we need to do. One more page. And then we can write a challenge for our classmates. So I'm working by myself. I'm not going to do that part, but thanks for watching today. We looked at a variety of different systems. There was one unique system that was not linear. Even though we're studying linear systems of equations, sometimes it's nice to look at one that is not a system so you get an idea of what all the options look like. But again, thanks for watching. I'll talk to you soon.